Hey, this is Julian Darden with Physics 2211. This is Lab 3, finding the mass of a black hole. The purpose of this lab is to find the mass of a black hole that interacts with a star that we are given the information for. We're assuming that the only force acting on this star is the gravitational force by the black hole. Using Newton's law of universal gravitation, we can find the mass of a black hole, that is shown F equals G, 6.67 times e to the negative 11, times m1 m2 over r squared, m1 being the mass of the star, m2 being the mass of the black hole. In order to find the mass of the black hole, we have to manipulate Newton's law of universal gravitation. So I've changed the formula here as shown right here to find black hole dot m, which is the mass of the black hole. So that is r squared times f net over g times the mass of the star. So the variables we need to find with our code are r, g, which we have, which is 6.67 times e to the negative 11th, the mass of the star, and f net. We were given some initial conditions in the lab. These initial conditions are the mass of the star, which is 2.2677 times 10 to the 27th kilograms. Our time step is 86,400 seconds, which is 1 day, and the position of the black hole is the vector -3 times 10 to the 10th, 0, and 0. We plugged these initial conditions into our code as follows. Star m equals 2.677 e to the 27th, that's the mass of the star, and delta t equals 86,400 seconds, which is 1 day. The position of the black hole comes in handy whenever we try to calculate r, which is one of our variables that we need. R equals the square root of the x position plus 3 times 10 to the 10th squared plus the y position plus 0 squared. 0 because the initial condition of the black hole is 0 in the y coordinate. We find f net by setting dp dt right here equal to delta p over delta t. So f net equals dp dt. I set my code to print the f net and the r variables because that is what I need to plug into Newton's universal law of gravitation to find the mass of the black hole. I will run my module for you here so you can see this. You can see the individual forces represented by the arrow scales, and the green ellipse motion is the orbit of the star around the black hole. So my code printed out these variables for me. F net perpendicular is equal right here. This is the number 2.4588 times 10 to the 24th, and r equal to 1.882 times 10 to the 12th. I entered these into the manipulation of Newton's law of universal gravitation in my calculator to find the mass of the star, the mass of the black hole. So when I calculated the mass of the black hole, I got 5.757 times 10 to the 31 kilograms. This is 29 times the mass of our sun. That's pretty big. The answer to the physics questions, if we were to change the mass, if we were trying to change the mass of the black hole, if the only force was the gravitational force acting on the star by the black hole, there is no other mass of a black hole that could give us these same initial conditions. I inserted this mass of the black hole in the web assign, and thank goodness I was correct on my first try. So thank you for listening. This has been Lab 3 for Physics 2211.